to confuse us, Sean.
No, sorry, it was not connecting properly, but I am here. To show how many other people are joining us tonight.
Well, I think it's us three.
Hello, good evening, everybody. Welcome to our Tech Tuesday. I know we're a little bit thin on the ground today, but that's fine because this gets recorded and we'll send it out. And please feel free to share it with whoever you would like to share it with. All these talks do get uploaded to my YouTube channel. So if anybody's looking to log on to the YouTube, you just look for Vital New You, which is where it's sitting under, and you can then find all the previous talks, share them, let everybody else know, and yeah, hopefully I can help a few people. So tonight we're starting a new series, and that is protein. Protein is our basis, it's our building blocks. It's obviously we know the body is made up of a whole lot of cells, but what builds those cells is protein. So essentially we are one big protein being. But what is protein and how does it work? Let me share my screen and I will show you exactly what it is and how it works. A few of these other goodies over here. And me. So protein, the good, the bad, and we won't go to the other part, but why do we need it? What is it? The very word means to come first. So the word means of first importance. So without protein, we don't exist. We can't exist. And protein is the central substance which makes life possible on Earth. Its very existence and nature are a mystery. Well, yeah, if you know God, you know it's not that much of a mystery because He created it, but each to their own belief. Proteins and the amino acids from which they are made are very complicated substances. So you can't have a protein without an amino acid. And dependent on which research you go with, there are 22 amino acids which are involved in building a multitude of proteins. Think of the alphabet. The English alphabet, other languages I know have other alphabets, but we're talking the English alphabet. The English alphabet has 26 letters. And think how complex the English language is, just made up of those 26 letters. Now, protein is a similar thing. You've got 22 amino acids. Think of those amino acids as letters. So those letters create a whole complex language of their own. So those 22 amino acids make up proteins. So different combinations make up protein as we know it. Exactly the same as the 26 different letters make up this complex language we call English. 9 of these amino acids are considered essential because they cannot be manufactured in the human body. So again, think of your alphabet. Take out 9 of the 26 letters. And do you think you could make up any comprehensible language out of that? Makes that much of a difference. So these 9 essential, 9 out of the 22, less than 50%, without them, your body can't create a protein. So they need those amino acids from our diet. If you aren't getting those 9 essential amino acids from your diet, you're in trouble. Non-essential amino acids can be conditionally essential as a result of conditions such as stress, toxicity, or pregnancy. So your body might be able to create them, or it might not be able to create enough of the non-essential amino acids, meaning that maybe it can create them, maybe it can't. You still need a good balanced diet to be able to get the full picture of the full language. So the amino acids linked together to form chains called peptides. Now, think of a spider's web. Have you ever watched a spider? My apologies, I'm losing my voice over here. It's not your signal. But if you've watched a spider launch itself from a tree, for instance, drops down on a long web, but that little single line can't do anything. It's got to make up a complete spider web to be able to be effective. So having the amino acids making up a chain, a single chain of peptides, is not really going to do anything. It needs the entire web to be effective. Peptides are proteins. So if you think of your chain of amino acids, they're a chain of peptides, but they're actually useless. They don't do anything. So only when you mix them all together, the peptides then become a web, which becomes your protein. I hope that all makes sense. So the arrangement of amino acids in a protein must be very specific for the protein to function properly. Think of an email. You can type up an email and you can press send, but if you don't have an address, where's it going to go to? Think of a cell phone. You can have a cell phone right there, and it's a cell phone, but it's pretty useless until you punch in the correct numbers to make the phone call to another cell phone. Because if I've just got my cell phone and I go, hello, it's pretty useless until I punch in the correct combination to get the correct number on the other side, to get somebody else, one of you, to talk to me. So the arrangement of the amino acids in a protein have to be very specific for the protein to function properly. Most cell numbers have got 10 digits. If I type in 9 and I hit call, absolutely nothing is going to happen because it's not a complete number. Therefore, the cell phone doesn't know what to do with it. Therefore, the call can't go through. So if we are missing a couple of amino acids, that means that our chain link of peptides is weak and it can't form the protein that we need to do whatever that protein has to do. So it's quite a fascinating and interesting system. Folding is what happens for these proteins to work. Proper functioning of the proteins is dependent upon proper folding. Now I'm going to tell you another little story. If you've ever been skydiving, do you think that your parachute is going to open correctly if it hasn't been folded correctly? Do you want somebody to just take this whole big pile of parachute and go, roll it up in a pile and shove it in a bag and stick it on your back and bail out of an aircraft and go, oh, I think this is going to tangle up, work, not open up at all, stay in a complete total granny knot inside your backpack, and you're now hurtling towards the earth? No, you want it. There's a specific way, and in fact, you have a profession of people who fold parachutes, and there's a specific way of doing it, because from the time that you either pull your ripcord or release your drag chute. Now, I'm not a skydiver, so please bear with me, but I am interested in it. Maybe one day I will step out of an aircraft. I have stepped off a couple of bridges in my time, but yeah, one day we'll do it. But in order for that parachute to actually open in the correct way and bring you safely to Earth, it has to get packed in the correct manner so that when it opens up, it doesn't candlewick, it doesn't bunch together. It needs to open up in the correct canopy to protect you, to bring you safely down to Earth. And the same happens with the protein. If it is not folded correctly. It can't unfold correctly to create your protein parachute to do the activity that the protein needs to do in your body. Now, nearly all types of proteins bend and twist back and forth in an amazing, highly complex three-dimensional pattern. I tried to find a video on how this would work, but I couldn't, unfortunately. If these folds do not occur in the proper way, the protein cannot perform its function in the body properly. Our parachute, the ground, if they're not working together, well, you become a big blob of protein on the floor. It doesn't really function. Quite graphic, I know, but that's how it works. Now, cooking can destroy this elaborate three-dimensional folded pattern of protein. Proteins hold a tight or hold a straight line pattern while being synthesized. So they've got to be straight like a guitar string. As soon as a new protein has been manufactured, it automatically folds itself into the correct three-dimensional pattern in a fraction of a second. Again, think of parachute, think of spider web. When your parachute first opens, it's a long string of string and nylon material. And within, hopefully, a few seconds, takes longer than, or protein takes less time to form than your parachute does, but you've got you've got your strings, you've got your canopy, and it now has to unfold correctly to form a canopy to do its job. Proteins have parts which, like water, and parts that don't. So I'm not a big fan of jumping in a swimming pool, but I like water to drink it. So some parts of my body like water, some parts don't. Pretty much like you, I would guess. Water-fearing protein components fold to the inside of the protein molecule, think of an umbrella, while the parts that like the water move to the outside. Umbrella, outside part, likes the water, repels it, inside part keeps it dry. So how does protein and DNA work? Proteins used to build our body, all of this is protein, are built using the DNA template. Very much like I've put together this PowerPoint, I start with a template and then I fill in a whole lot of letters to create, hopefully, what comes out as something that makes sense. But without the template, without the correct letters, which is your amino acids, all you'll see on here is a whole lot of 26 different letters randomly generated all over a screen, doing absolutely nothing, making absolutely no sense. Maybe the rest of my talk doesn't make a lot of sense yet, but we'll get there. So the DNA is used to build RNA, which then builds proteins. It's a very complex thing, so please don't worry about all this higher grade stuff. It was always higher grade to me as well. I'll try and remember what DNA stands for. It's deoxyribonucleic acid, I think it is. And the RNA is a ribonucleic acid. Something along those lines, but don't worry about what the actual letters stand for. Just know that they're there. One RNA molecule can manufacture 20 amino acids per second. And we're just this random blob of protein in the universe that doesn't have a being behind it. I'll let you decide. Deficiency of amino acid intake in the diet will impair the process of protein manufacture in the body. So if we're not getting in the correct building blocks, we can't become us and we can't function correctly. So when we look in a mirror or in a camera screen, most of what we see is protein. This includes the skin, the hair, the nails, the muscle, don't have a lot of that, internal organs, hormones, and even the molecules of the immune system, which allow us to fight off invaders or heal from wounds. Our body is a mind-blowingly fascinating being, and I cannot even begin to fathom all the little intricacies, but I know that everything works together in a complex manner that is still baffling to most scientists. They might think they know how everything works, but there's an awful lot of information out there that they are still clueless. They know it works, but how it actually works, they don't always know exactly. So what happens if we can't get this protein or the amino acids into our DNA to form the protein? A deficiency of amino acids can be a result of at least 4 major factors. Firstly, protein may be difficult to break down and digest. Now, some of the proteins that come to mind right now, nice juicy steak that I had for lunch today, an egg, a piece of fish, a piece of chicken. Those are all proteins. But once you've cut it up into bite-sized pieces and shoved it in your mouth, your body has to now break it down into individual components, into individual amino acids to recreate the protein that is us. Secondly, medical interventions such as the use of antacids or surgery for the removal of part of the digestive tract may impair protein digestion. And I see this regularly because, for those who don't know, I do work in the medical field. I am not a doctor. I don't pretend to even be close to knowing even a small percent of what a doctor knows. But sometimes, for whatever reason, be it traumatic injury, be it cancer, they have to remove part of the bowel. And our bowel or our digestive tract is incredibly complex. And every last millimeter of the however many kilometers of it there is there for a reason. Take out part of it, you're going to have a problem digesting your protein that you've taken in. Now, thirdly, the functioning of the digestive tract may be impaired by inflammation, bacterial overgrowth, allergy, or other disease processes. Again, I tell you, our body is an amazingly complex machine. Think of a car engine. You remove one little item, loosen one wire, take out one fuse, and this really complex machine is a really complex piece of metal because not everything's working. Once you turn that key or push the button, there's a whole lot of things that have to happen in order for your engine to kick, turn over, and drive the car. Lose a couple of those things, sometimes they're very, very small, and your car goes nowhere. Same with your body. Now, finally, aging and poor nutrient intake can result in decreased production of the hydrochloric acid and enzymes necessary for proper breakdown and assimilation of the protein. Again, think of your piece of fish, your piece of steak that's on your plate. It goes in here and it's got to get broken down to be useful. Otherwise, it goes in here, very gross, I know, but falls out the bottom end and it does absolutely nothing. So what happens is when people have problems with their digestive tract and they're not absorbing nutrients, they might be eating lots of food, but they're not absorbing anything, and therefore they're not getting any nutrition. Again, I will say it again, like I've said on more than one occasion, diet is what you eat. Nutrition is what your body absorbs. So it doesn't matter what you're putting into your mouth. If your body can't recognize it, can't break it down, can't use it, absolutely useless. So things that are difficult to digest. Some foods, such as soybeans and other legumes, contain digestive inhibitors as a defense mechanism to prevent them from being eaten off the face of the earth. Even plants are complex things. Animals have got all sorts of defense mechanisms to prevent them from being eaten. Humans have got all sorts of defense mechanisms to prevent us from being eaten by other animals, maybe. Plants have defense mechanisms to try and prevent us from eating them. These foods can inhibit digestion of both carbohydrates and protein foods through inhibition of digestive enzymes. Think of those enzymes as acid that basically breaks the carbohydrate or the protein down into something usable. Heat processing of foods may also alter both the protein structure and the digestibility. The precise factors are not known still today, very much like the common cold. We know we get it. We know it makes us feel really yucky, but we don't know how to prevent it, how to prevent ourselves from catching it. Ordinary cooking precipitates proteins, rendering them less easily digested. Think of an egg. An egg eaten raw is protein. I'm not too sure about you, but I don't really want to eat raw egg. But when we cook it, now we've destroyed that protein. So it's still protein, but not as effective as what it would have been we have had it raw. One of the peculiarities of protein is that it can change from liquid to solid when heated. Again, think of the egg. The process of digestion of protein is called hydrolysis. It involves inserting water molecules between the individual amino acids in the protein chain. Very, very complex thing, this. Changing the nature of protein so it does not relate as well to water cannot help but make protein foods more difficult to digest and utilize for nutritional purposes. So we know we need protein. We know we need protein. We know we need the amino acids to process the protein. But the tricky part comes in getting that protein into our body in a way that the body can actually use it. One of the byproducts of heating protein foods, which also contains sugars, is a browning effect, otherwise known as a Maillard reaction, in which the amino acid lysine combines with sugars. Studies have shown that heating of wheat products makes potentially allergic components of grains more resistant to digestion, greatly increasing the allergenicity of the grain. Think about taking your raw grain, creating bread. This is why people get allergic to wheat products. We should not be surprised that heating of other foods increases the allergic sensitivity by decreasing the digestive efficiency. Very, very complex thing. Boxed cereals are often highly heated and contain large quantities of browned protein products. In the words of Dr. Jim McAfee, sometimes eating the box that the cereal comes in has often got more nutrition in it than eating the cereal that comes out of the box. How's that for a scary thought? This not only makes them more difficult to digest, but also results in absorption of what are called advanced glycation end products, otherwise known as AGEs, which obviously leads to aging before your time. AGEs induce inflammation in body tissues and speed the process of aging. So next time that you want to give your children or your grandchildren a box of cereal, think very carefully about what is happening and how that lovely looking sugary treat is being processed in your body and what exactly it's doing to their very sensitive digestive process. I'll let your mind go wild with that one. When protein foods are blackened, they become even more difficult to digest. So that nice juicy piece of steak that's been put on the barbecue, or braai if you're South African, and you don't really want it walking off the coals, but you want it dead enough that it's really blackened. Well, that's pretty useless as well. Browned and blackened proteins are potential mutagens, meaning that they can mutate into all sorts of nasty things, and carcinogens, which means cancer causing. So Louis Smith will tell you a lot more about that when he talks about barbecued foods and his reaction or bout to cancer that he had. Remember, he was diagnosed with cancer at an early age. And if you listen to his story, he will tell you that barbecue was one of his favorite foods. They would cook it every night. Think about that when you're next having a barbecue. And these things, the mutagens and carcinogens, can damage the DNA. Medical interventions. The administration of antacid medications to patients in the hospital setting is very common, even though protein is essential for healing. You go into hospital for surgery to heal a problem, and then they give you other things to make some of those problems a lot worse and a lot more difficult to heal. See, I'm running out of time over here. Between 40 and 70% of patients admitted to a hospital are given some form of acid suppressive medication. I know when I see patients in hospital, they have these long shopping lists or menus of medications that they're given for all sorts of funny things over there. Up to 70% of these patients have conditions for which there is not support for acid suppressive medication in the medical literature. So next time your doctor prescribes a whole lot of things, please ask him what or her, what are they prescribing and why are they prescribing it. Half of patients put on antacids while in the hospital also receive a prescription when they leave. Again, ask your doctor, and if they don't know, ask your pharmacist. What is the stuff that you're giving me and why? What does it do? Antacid medication was shown to increase the risk of hospital-acquired pneumonia by 30%. That is quite scary in my opinion. The acid secretions of the stomach are essential for proper breakdown and absorption of protein. Routine use of antacids in or out of the hospital carries the potential for creating amino acid deficiencies. Next time that you have heartburn or indigestion, think twice before reaching for the antacids. And if you've got a friend or family member who suffers from this condition, advise them as well. Antacid use also increases the likelihood of developing an allergic response to protein foods, and may also increase the severity of the allergic response. Most gastrointestinal surgery has negative effects upon nutritional status because the gut, as I've always said, is extremely sensitive. Mess with the gut and you will not be a happy camper. And that is where I'm going to stop it for this week. Let me stop my share. Oh, good, we've got a lot more people now. Does anybody have any comments or questions before I stop the recording?